In this lesson, we're going to graph two lines and see where they cross. That's what solving systems means. First, we're going to review graphing methods. The easiest method that we have is when our equation is already in y equals mx plus b form. So here's your two steps that I'm just reviewing for you. Your first step is to place the y-intercept. That's the first thing you're going to do. The y-intercept, that's your b, right? And then the second step is to count out the slope from the y-intercept. So your slope is your m. All right, let's do that. We're going to graph lines 1 and 2 on the same set of axes here. Let's start with, so step 1 is to place the y-intercept. That's the b. So what is the b value for equation 1? The b value is 4. So my first step is going to be to place the 4 on the graph here. Then my second step will be to count out the slope, and the slope is -2/3. So before I can do anything on the graph, I'm going to have to put a scale on there so that I can count everything out evenly, and so that I'm identifying what I'm going to count by. So I'm going to count by ones, but I'm going to label, actually I don't think I'm going to count by 0.5s. I think that'll work. I'm going to count by 0.5s, but I'm just going to label every second one. So on the x-axis, 1, 2, 3, oops, 4, and 5. And the same, I have to use the same scale on the other side of the x-axis. I can't change it and now all of a sudden count by 3s or something. Now I'm going to use the same scale for my y-axis. You don't need to skip count. I'm just kind of looking ahead at where I know the answer is going to be, and so I'm spreading things out a bit. But it's fine to count by ones, because if you do count by ones, then you're going to actually get more grid space in there. So if our point of intersection turns out to be 12, 8, that would be it would be off my graph because I chose to count by these intervals. So you can count by ones to make sure you're going to fit it in. I just happen to know where this is going to end. So first thing I'm going to do is step 1, place the y-intercept. The y-intercept is a 4. That goes up the y-axis. There's my 4. My second step is to count out the slope from the y-intercept, and the important word there is from the y-intercept. So my slope is -2/3. That means I'm going to fall 2 units, and then I'm going to run 3 units from here, from the y-intercept. So I'm going to fall 2, remember your scale, so falling 2, 1, 2, that's falling 2, and I have to run 3, and again my scale I counted by 0.5s. 1, 2, 3. So there's my second dot. That's all. And now I'm going to draw a line connecting those. So I'm just using my kind of ruler function here to try to get this line on there, because when I try to use my ruler it doesn't work very well. So I'm going to put arrows on the end of that. Arrow there and an arrow there. There's my first line. It's a bit messy. I'm going to erase those arrows and fix them a bit. It's important that you don't just draw the line between your two dots, because what we're looking for today, we're going to be graphing a whole second line, and I need to see where that crosses. If I only graph the point in between these two dots, and let's say my second line comes up like this, then I would never see the point of intersection because I only graph between my two dots. So you always want to extend it to cover your grid if you can. So let's take a look at that second graph, or the second equation. First, the b value. So step 1, place the y-intercept. My y-intercept is the constant and its sign, so that's a -3. So let's go right down and put that on the graph. -3. My next step is the slope. There's an invisible 1 in front of this x, so my slope is a 1. That's really a 1/1. So I'm going to rise 1, and I'm going to run 1 from the y-intercept. So rise 1, run 1. And again, because I counted by halves, I have to actually go 2 squares instead of 1. And now we're going to draw a line connecting those two and make sure, I'm not going to just draw it between here and here, I need it to cross this line. So make sure it extends to cross the red kind of purple line. So I've got an arrow here and an arrow here. Now I'm looking for the point of intersection. That's what it says underneath here. What is the estimated point of intersection for each of the graphs above? So the first one, estimated. See the word says estimated because I'm using a graph and I'm just doing the best I can. So my point of intersection is right in there. That's where the two cross. What does that coordinate look like? So I'm going to use decimals. I'll use one decimal place. So it's bigger than 4. Let's say 4.1 maybe. It might be more than that. 4.1, 4.2, something like that. And then the y value is greater than 1, but it's not as much as 1.5. That would be the next line up. So we'll say 1.3. But you're looking at your graph and you are getting the point of intersection from your graph. So for our first question here, our point of intersection, I'm going to write that in short form, point of intersection, POI, is, now it's estimated, so it's about, this isn't exactly right, but it's about 4.1, 1.3. Now if we were doing this on a graphing program, we could see exactly by clicking on it what the estimated point of intersection is. So now let's look at the next example. I'm going to scroll up. This one's a little harder because this one was already in y equals mx plus b form. This whole part was really easy to do, but this is standard form. We're given standard form. When you're in standard form, x plus b, y plus c equals 0, or any other form, no matter what form it is, we have to first, we're going to have to rearrange it. So what we do is we isolate y. That's the main step right there. Isolate y, watch the signs. B, rearrange the following equations in slope y-intercept form and then graph. So this one, you can't tell me right away what's the, remember our first step over here was to get the y-intercept. I can't really see, the 6 is not the y-intercept. It's the constant, but it's the wrong constant. It's a capital C here. I need it to be a lowercase b, which means I need to isolate y. Equation 1. So in equation 1, I need to isolate y. I want y all alone. So the first thing I'm going to do is subtract 2x from both sides, and that will bring it over. Now these aren't like terms, 6 minus 2x. So negative 3y equals 6 minus 2x. I can't put them together. I'm going to put the 2x first because we're used to having the x before the constant. So I'm going to write it like that. Still not done. Y isn't isolated. To isolate y now, I'm going to divide both sides by divide all pieces by negative 3. So these negative 3's cancel out, and I have y equals negative 2 over negative 3. Two negatives are going to make a positive, and I'm going to get 2/3 x, and then positive 6 divided by negative 3, that's a negative, and 6 over 3 is 2. Now I'm in y equals mx plus b form. Now I can go over and do the graph the way I did over here. So this time I could also count. I could also skip count like I did over here and count by 0.5s, but I'll just count by 1s this time just to make it easier for you guys to show you. Actually, I'm going to label every second one to show you that if you count by 1s, you might have more space on your graph, but it's easier to count by 1s to start because then you know for sure you're going to get the point of intersection. You're not looking ahead like I am able to see what the answer is going to be. So there we go, and I'm going to do the same on the y-axis. Can you press pause and do this on your own without me showing you how to, and then come back and it'll be done. All right, so now the first thing we do, remember, is we place the y-intercept. This is my b value right here. My b is negative 2, so I'm going to place that. Negative 2 goes right on there. That's the first thing you do. The next thing you do is you count out your slope, and this number is my slope. So I have a rise of 2 and a run of 3. So I'm going to rise 2, and this time I'm only counting by 1, so I'm going to rise 2, so that's 1, 2. I'm going to rise 2, then I'm going to run 3. 1, 2, 3. There we go. Put Put a dot there, and then draw a line through those two dots, and draw a good line through it, not just a little tiny line segment. So there it is, nice and long. I don't know where the other line is going to cross it, so I want to make sure I have a long enough line. Next one. Rearrange the following equations into slope y-intercept form. That's this form here. And then graph. So this one isn't, neither was this one. They're not really fully standard form, but any form that is not in y equals mx plus b, we have to isolate y. So to isolate y, I want to bring the 8 over to this side, so I'm going to subtract 8 from both sides. That's just going to give me x minus 8 equals negative 2y. I want to isolate y, so I'm going to divide both sides by negative 2. Everything gets divided by negative 2. That leaves me with, let's start on the right here, that's going to leave me with, these two cancel out, that leaves me with my isolated y, beautiful. Then over here I have x over negative 2. We're not allowed to have negatives in denominators in math, it's not good form, so I'm going to move the negative up, and I'm actually going to put an invisible 1 there, so that's really a negative 1 over 2x, and you can put the x on the top or in the middle, doesn't matter. And then negative 8 over negative 2 is positive 4. So now I have to graph this line. How do I graph it? I want to start with the y-intercept. This is kind of in the wrong order. We're used to it being y equals mx plus b, but I've got my y over here, which is fine. I should still be able to identify the m and the b. So the b value is the constant, so my b value is a 4. So I'm going to put that on first. Put a dot up here at 4 on the y-intercept. My m is my slope, and that's the number that's always attached to the x. The coefficient is a negative 1/2. So that means from negative 4, I've got to drop 1, and then run 2. There's my second dot. So I'm going to draw a line between those two dots. Okay, again, nice long line here. Arrows on the ends. And then, of course, the question below is, where do they intersect? So our first one was A. I should have put an A here. That was A. Here we are on B. Where do these ones intersect? What is the POI here? What's the coordinate there? The point of intersection is about, so you're looking at your graph, and I'm looking at my graph. I think it's a, let's say 5.2, maybe a bit more than that, 5.3 and 1.5. Okay, and your numbers might be a little bit different. Whenever I'm marking a test or a quiz, everyone's numbers could be a little bit off. I'm not expecting the exact same answer from everybody, but certainly they should be pretty close. Recall that the equations of two lines, recall that the equations of two lines are together called a linear system. Only one, if you just have one equation, it's just an equation. So this is a system, and this is a system, because we have more than one. Here's an example here. Consider the linear system negative 100x plus 125. Oh, those are big numbers. And 50x minus 475. Oh, again, big numbers. Graph both equations on the same axes. That means we're putting them together. Since the numbers are so large, we'll need to first think about the scale that we want to use before we graph it. And we will look at the y-intercepts to help us figure out that scale. So they're already in y equals mx plus b form. So here is my m and my b for my first one, and my second equation, the m is a 50 and the b is negative 475. So I want to graph these, and I can graph them quickly using this method we talked about up here, right? Just find the slope, find the y-intercept first, then the slope, put it all on the graph really quick. But these are really big numbers, so I'm going to have to think a little bit before. I can't just count by, use a scale of ones. So look at the y-intercepts is the clue here. I have a y-intercept of 125 and a y-intercept of negative 475. So I want to make sure to include at least those values. I'm going to count by probably 100. 1, 2, 3, 4, 5. Yeah, I could probably count by 50s. These numbers aren't that big. So here you could decide on my y-axis, do I want to count by 50s or by 100s? You need to get negative 475 in there. Well, let's do 100s. That's probably easier for most of us. So I'm going to skip again. The problem with making a larger interval, I'm counting by 100s instead of counting by 50s, is it's a little harder to be more accurate with the point of intersection when you have a really big scale like we have here. Negative 200. So we still have to think about the x-axis, but this was how we got our y-axis. So let's go ahead and put on our y-intercepts. So I haven't got my x-axis scale yet. I haven't thought about that yet. I'm going to do this first. First I have a b of 125. So you can see if I counted by 50s, it would be a little easier to graph 125, but because I counted by 100s, it makes it a little harder. And that's why you wouldn't want to count by 500s, it would be really difficult. And when I look at that, that's my first y-intercept is 125. My slope is negative 100, which means from here, I'm going to have to drop 100 and run 1. So I don't want to count by 100s here, in this case, for this question. If my slope was negative 100 over, I don't know, negative or positive 92, then if I had to fall 100 and run 92, I definitely would not count by 1s. I would have to change that. But since my slope is negative 100, that's really negative 100 over 1. So I have to fall 100 and I only have to run 1. And the same thing's going to happen on the other side. Well, let's put the pink one on. I'm going to put negative 475 on here. And then from that y-intercept, my slope for this one is 50. So that's really 50 over 1. So I'm going to rise 50 and run 1. So when I rise 50, running 1, I don't want to count by 100s. I'm going to count by 1s. Actually, I'm going to even spread it out. Since both of them are just running by 1, I only need to go over 1 to the right for each of these. I'm going to count by 0.5s, just so I have a little more room to find my point of intersection. 2, oops, sorry, that's a 1, not a 2. I just said I was counting by 0.5s. 1, 2, 3, 4, and so on. On the negatives, I'm not even going to really need to go in this direction. Let's go back to the blue one. I want to graph this slope here. So remember this, where I'm at right now, this is 125. I want to drop 100, that would take me to 25, and run 1. So right about there, and then I will put a line through those two. Arrows on there. I probably went a little further than I needed to. There's my blue line. Now my pink one is y equals 50x plus minus 475. So here's my slope. From my y-intercept of negative 475, I've got to rise 50. If that was a negative 475, that's going to take me to negative 425, and I'm going to run 1. So that's about there. And then a line through these two, and I can see that it's going to cross down here somewhere once I put my line in. And arrows, because these lines continue on to infinity. What is the point of intersection? Oh, I didn't even read this. I should have read my own instructions. Let's count by 2 along the x-axis and count by 50 along the y-axis. Oh, I should have read that. So 50 would have been better, right? But that's okay. Let's take a look at where our point of intersection is here. Scroll down. Check the coordinate of the point of intersection in each of the original equations. So first of all, what is our point of intersection? POI. What do you think it is? X value looks to be about 4. And the the y value here is, so it's not 300, it's negative 275. Put there. Now let's check this. Check the coordinate of the point of intersection in each of the original equations. If I had used the scale that I suggested that we had used, it would be even clearer, the point of intersection, because we counted by 100s, which made it harder to see, and this was probably what I meant here. I wouldn't have meant count by twos, I probably meant count by half. So that one was okay. Equation 1. Equation 1 was the blue one. What is the left side of equation 1? I'm gonna have to zoom out here so I can fit everything in. Nope. Okay, equation 1 is negative 100x plus 125. So the left side here is just the y. Remember, left side, right side? Left side, right side means I draw a line through the equal sign and I divide it like that. So this is my left side, this is my right side of the equal sign. So my left side is y, is just a y. My left side is a y. My right side is negative 100x plus 125. Negative 100x plus 125. That was the equation. So what I'm going to do now is check my point of intersection. This is an x, this is a y, so let's sub in. So the left side instead of y is now negative 275. My right side is negative 100 times x. X is 4 plus 125. That gives me negative 400 plus 125. So did we get our left side to equal our right side? Well, we absolutely did. This is negative 275. So what that means is 4 negative 275 is on the blue line. That's what that means. It's on the blue line for sure. It doesn't mean it's the point of intersection, because if that point of intersection doesn't work in equation 2, then all we've done is prove we found a spot on the blue line. I could sub in anything here. I could sub in this point into the blue equation and it would work out left side, right side. I don't want any point, I want this point. I want to know if this is my point of intersection. So now I have to take that point of intersection and sub it into the pink line and see if we get left side equal right side. Then it will mean it's on the pink line. So equation 2, the left side was y equals 50x minus 475. So we had 50x minus 475. Now we want to know if this coordinate is on the pink line too. So in for y, I put negative 275, again, same as the other side. Now my right side this time is 50 times x, x is 4, minus 475. 50 times 4 is 200, minus 475. Yes, again, we get negative 275. So this tells us that the point of intersection is on the pink line. So if it's on the pink line and it's on the blue line, on the pink line and blue line, if this point is on the pink line and it's on the blue line, then it must be the point of intersection, because straight lines can only cross once. So as soon as you find the point that is on both lines, it means you have found the solution. The point of intersection is the solution. So the solution is 4, negative 275. So the solution is the same thing. Whoops, that should be a highlight, not a pen. The solution is the same thing as the point of intersection, and in that case it's right here. And its point of intersection must work on both lines. So you should practice questions like that on your own. It's good practice for how to graph straight line and then substitution. All this is substitution down here.